Hey there. So I decided to make some videos for you guys since we're off on Monday, and this was one of the questions on the worksheet. So balancing equations, very traditional type problem. In general, it's just trying to keep track of atoms, right? So we're trying to figure out what coefficients go out in front of every molecule on the left and right hand side of the equation. So you'll see it done in different ways with different people. This is just my way. I tend to like to split it up physically and just start accounting for all the atoms. So literally create a list of what we got. So we have magnesium, we have a nitrogen, we have a hydrogen, and an oxygen, and also magnesium, nitrogen, hydrogen, and oxygen. So on the left-hand side, I like to start with what we have first. So we have 3 magnesiums because of that subscript on the left-hand side, and on the right-hand side we only have 1 because it doesn't have a subscript attached to it. Nitrogen on the left is a 2, and on the right-hand side there's just 1 right now. On the left for hydrogen we have 2. On the right, this is where people forget to count both molecules. So on the magnesium hydroxide we have 2 hydrogens. On the ammonia we have 3, so we have a total of 5. On the left hand side for oxygen we have a 1, and on the right hand side we have a 2. Okay, so that's just the beginning, right? So now you have to actually start inflating the numbers to make them match. So it starts out 3 versus 1 for magnesium, so we need to inflate this, scale it up to a 3 by putting a 3 coefficient out front. But that changes oxygen and hydrogen. So you'll notice that there were originally 2 oxygens per hydroxide. Well, now there's 3 of them total, so we have a total of 6 oxygens, looks like. And for hydrogen, we also have 6 in the hydroxide molecule, but we're also adding to it what's in the ammonia. So this went to 9. Okay, can move on to nitrogen. On the left-hand side there's 2, right-hand side there's 1. So what are we going to do to the right-hand side? We're going to put a 2 in front of it. But that also increased the number of hydrogens. So you'll notice there are 6 hydrogens in the hydroxide molecule, but now there are 6 in the ammonia molecules. So we have 12 hydrogens. Before we move on, if you don't do that, you might forget. Because when you move back to the left-hand side and you notice there's 2 hydrogens, we need to inflate that to match now 12, not the 9. So we're going to increase that to a 12 by putting a 6 out front, because 6 times 2 right there is 12. Cool. Moving on to the oxygen. Oh, look what happened. It did it for us. If you actually updated your list, it did it for us. So you'll notice that there's inherently a 1 there. If it's empty, it's a 1. It's not a 0, because that would mean the molecule is not there. But we have a 1, a 6, a 3, and a 2 for this reaction. So good luck with the rest of the balancing of the reactions, and you'll probably see a few more videos. Okay, bye.